Example 3. Suppose that the angle of elevation of the sun is 23.4 degrees. Find the length of the shadow cast by a person who is 5.75 feet tall. Round to the nearest tenth as needed. All right, we first need to draw a sketch of this situation. This is a shadow problem, okay? A word of warning, shadow problems are going to be very popular in calculus, okay? So you want to understand how to draw them, okay? So first of all, we are going to need a horizontal, okay? This can represent the ground, okay? So we'll go ahead and say, here's the ground, and there is a person, okay? So here's the person, and we know that this person is 5.75 feet tall, okay? And then there is the sun, okay? The sun is casting a shadow, okay? So here we go. I don't really have yellow. I can make it yellow. Okay, so here's the sun. Yay. Okay, it is going to cast a shadow. Okay, the way it's going to work is this. Okay, so you've got your sun. Okay, the sun, you can think of it this way. The sun like kind of casts down over this person's head like this. I'm just showing you how to properly draw a shadow problem here. Okay, so it's going to do something like this. Okay, and then I'm going to extend the ground by a little bit over here. Okay, so like that. Okay, so what you see is you just want to imagine the sun kind of beaming down over the top of this person's head, and the shadow is going to be created. Let me see if I can find a gray highlighter here so that I can color it in. Okay, so here we go. This is going to be the shadow. Okay, right here. Okay, this is how we can think of it. Okay, this is going to be the shadow. Okay, what we can do, okay, because this is now set up. Okay, you see the ground, the person standing on the ground, you see the sun beaming down and creating a shadow. Okay, so what we will see here, if we kind of, extend this, we can make two different right triangles here. Okay, you can think of this as a right triangle. Okay, if we draw down from the sun here. Okay, so like this is a right triangle, and then we can have another right triangle if we draw through the center of the person. Okay, the person's size other than their height, is irrelevant. Okay, so when you do all these drawings and like you're trying to configure your right triangle, you were just kind of drawing through the center of the things. Okay, see, I have this point right here that's kind of the center of the sun, and then I'm drawing this smaller right triangle right here through the center of the person. Okay, so we kind of center things. Okay, but here is the situation. I'll go ahead and put right here that this is the shadow. We are trying to find the length of the shadow. Okay, all right, so again, I want you to really focus on these shadow problems. They are going to show up in calculus. They will be different. You will be calculating things like finding the rate at which the length of the shadow is changing. Okay, so it's going to be knocked up a notch. Okay, but just for right now, we're learning how to set up these shadow problems and just simply calculate the length of the shadow, assuming that this person is standing still. Okay. All right, so here we go. We also, in our sketch, we can add another piece of information. We know the angle of elevation of the sun is 23.4 degrees. Angle of elevation is a lot easier to identify than angle of depression. Angle of elevation is formed from looking up. Okay, you can follow the same definition as angle of depression. The angle of elevation is going to be formed, well, there really isn't exactly a line of sight here because we don't really have the person looking up, but you can imagine you do want to associate the angle of elevation with looking up. Okay, so in this particular problem, from this point, okay, if someone were looking up at the sun, okay, That would be the line of sight, and then the ground would be the horizontal. This is going to be the 23.4 degrees. Okay, angle of elevation here, like I said, it's more straightforward. It's the angle you assume it to be. It's the one your gut is telling you. Okay. All right, so we've basically got everything labeled here. We've got our angle, you see the shadow, we know the height of the person, so we can get going, okay? We are solving for the length of the shadow. I'm going to go ahead and call that x. That is going to be our variable. So we need to use one of our right triangles because we have two here. So we are going to use the smaller right triangle here because it contains the shadow, okay? So we're going to focus in on this blue right triangle, okay? When we look at this, okay, if we go across from the angle of elevation, we know the length of this side right here, okay? This is the height of the person. That's the 5.75 feet, okay? And then we don't know the shadow, okay? This side right here is the hypotenuse, okay? And then the shadow is the adjacent side. Okay, again, we're focusing on the smaller triangle, not the bigger triangle. Okay, so what we do here with this 23.4 degrees, okay, we know the opposite side, its length is 5.75 feet. We are looking for the length of the shadow, which is the adjacent side. Okay, so I'm going to go ahead again and use tangent, okay, because we know the opposite side, we need to include the adjacent side because that is our unknown. All right, so we're going to say the tangent of our angle, which is 23.4 degrees, that is equal to the opposite side over the adjacent. The opposite side measures 5.75 feet. The adjacent side is our unknown value x. So our trig ratio has been set up, okay? So if I get rid of some of the opposite over adjacent here so we can see this a little clearer, the tangent of 23.4 degrees has to be 5.75 over x. We want to solve for x. Okay, so to get rid of this fraction, we are going to multiply by x. That way we have one in the top and then one in the bottom. They'll cancel. If we multiply on the right by x, we have to do it to the left side. Okay, so on the right, like I said, the x's will cancel. We'll get that x times the tangent of 23.4 degrees is equal to 5.75. Okay, we want to solve for x, which is the length of the shadow. Tangent of 23.4 degrees, when you pop that in your calculator, that is just going to be a decimal. It's just a number. So we can divide both sides by it so that we can isolate the x. Okay. All right. On the left side, these tangents will cancel. So to calculate x, we need to go to our calculator and punch in 5.75 divided by the tangent of 23.4 degrees. Okay, your calculator absolutely has to be in degrees here for this to work. All right, so let's go to the calculator. We're going to punch in 5.75 divided by the tangent of 23.4 degrees. Okay, make sure you're in degree mode. And then here we are. Okay, I'm going to write out this full decimal expansion and then we'll round as needed. Okay, so this is going to be 13.287 46601. Okay, the direction said to round to the nearest tenth. Tenth is one place after the decimal point. So here we go. We've got a 2, okay? And then if we look after the 2, we have an 8, so we need to bump that 2 up to a 3. And so we can go ahead and conclude that the length of the shadow is 13.3. You need to put the units down. I will ask you units for word problems. The person is their height is measured in feet, so we're going to keep the same units for the shadow. Okay, so we're going to say that the shadow is approximately, since we rounded here, the length of the shadow is approximately 13.3 feet.